Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 8 of the unit Electric Charges and Fields. Today we are going to discuss about the electric flux. So let's begin with the flux. What is it? First, we can say that it is the total number of lines of forces that passing normally, mind this word, normally through a given area. So let's say this is an area and 1, 2 and 3. These three lines are passes through this area. These three lines are passes through this area perpendicular to it. Look at this. Then flux associated flux associated with this surface is 3. Its unit of the electric flux would be Gauss. So we can say it is the total number of lines of force, or rather we can say total number of electric field lines passes normally through a given area that we call as an electric flux. Now let's say this is the surface and electric field would be in this direction, but what I want is the electric field should pass normally perpendicularly. So if I take a component with this is the E cos theta, yes, and this is area vector. Now this is ds and this is the area vector in this direction. So if I write d phi, it would be a ds into E cos theta, and this d phi should be is equals to E into ds cos theta. So this would be dot product of electric field and area vector. This would be the dot product of electric field and area vector. So what I can write is flux is equals to Es cos theta. The things would look like this. Flux should be is equals to E dot S, where E is the electric field, E is the electric field, and S is the area vector. Now area would be treated as an area vector, and direction of area vector. How could you determine the direction of area vector? It is direction of area vector normal and outward to the surface. It is normal, I mean perpendicular, and moving out to the surface. This is the direction of area vector. Remember this thing. So what we know up till now is that flux is E dot S. If electric field is already perpendicular to the surface, very good. If it is not, you need to take a component of this, and that needs to be dot product with the area vector. Now what is area vector? We know the magnitude of the area. That means if circle would be there, I can write area as a pi r square. If square would be there, I can write area as an L into L. It's an L square. And direction, it is normal, I mean it is perpendicular and outward to the surface. So flux is the total number of lines that passes perpendicular through a given area. Am I clear up to this? Am I clear? Yes. Would it be a scalar or vector? Would it be a scalar or vector? Yes, it is a scalar quantity. It is a scalar quantity. Flux is a scalar quantity. Remember these things. So let's look at how we can use it. Let's say, suppose a hemisphere is given, and through this hemisphere, this is, let's say, radius r, and electric field will be in this direction. Electric field would be in this direction. Yes. If I want to find it out, flux or rather I should say it's an outward flux. I should say outward flux. How could I find it out? Look at this very carefully. Now, when you find it out, flux, you require two things. First, direction of electric field, next direction of area vector, and you need to do a dot product of this. That means you required E A cos theta. You required E A cos theta. So at first task, this is the direction of electric field that I know. Now what is the direction of area vector? Look at this, you required an outward. So from this base, area vector would be in this direction. What was the direction of area vector? Remember, what was the direction? We said that area vector will be perpendicular and outward from the surface. It should be an perpendicular and outward from the surface. So if I write outward from the surface, this would be the area vector. So here theta is equals to 0 degree. Theta would be a 0 degree. So this flux would be E into A. Now this is E multiplied by area. Area of this base, which will give me a pi into r square. This is the flux, E into pi r square cos. Can you get it? Will you be able to solve some more questions like this only? Will you be? Are you sure? Would it be okay? Okay, let's find it out. Next numerical. Suppose you have been given a cylinder having height h, and let's say this is the radius, which is r, and direction of electric field would be in this. Direction of electric field would be in this. You need to find out, let's say flux inward, and you need to find out flux outward. How can you do it? Think it. How can you solve this? Now look at this. This is direction of electric field. So if I reconstruct this, this should look like this. Yes, because it is a perpendicular. Area vector. This is area, this is electric field. I am talking about the outward flux. This distance should be 2r, and this height as they have given, this is h. So flux outward would be E A cos theta. Here theta would be a 0 degree, so this is E into A into cos of 0 degree. So this is equals to E into A, and area is, it's a 2r into h Gauss. Now what about the inward flux? Think it. What about the inward flux? Look at this. Here direction of electric field will be in this direction, but when I consider the area vector, I need to move an area such as that this is perpendicular and outward to the surface. So this would be the area vector. Shall I repeat this? Look at this. What I need is, I need the inward flux. So inward flux, direction of electric field will be in this direction. Will you able to solve this up till now? Yes, But direction of area vector would be in this direction. Yes, it is perpendicular, look at this, and outward to the surface. So when I consider the inward one, I need to make an area vector at this position. So here it would be E into A multiplied by cos of 180 degree. Yes, and cos 180 is -1, so this is equals to minus of E into A is the 2R into H. Gauss. So this flux invert should be is equals to minus of E into 2R into H. Gauss. Yes, yes. Any difficulties? Are you sure? Are you sure? Okay. So let's move to the next question. Suppose that you have been given an electric field which should be 3I plus 4J plus 5K Newton per Coulomb. You need to find out. Calculate the flux through the surface or surfaces bounded by following curves. Let's say first it is x square plus y square is equals to r square. First tell me what is this? Which curve will it represent? Yes, you are correct. It is a circle having radius r. This is a circle having radius r. In which plane is it there? So I can write like this. This is, let's say, x. Let's say this is y. And in this xy plane, it is there. This is its radius. So its area vector. If you cannot assume this, just think that on whichever the floor you are sitting, consider one of the dimension as x, another dimension as a y, and put a circle on that plane only. I repeat, put a circle on that surface only, and that circle should be having a radius of r. Now try to assume that certain certain fields of lenses are moving outward but perpendicular to this circle. Yes, can you imagine this? Yes. Okay, so what would be its area vector? It's in pi into r square, that I know. What would be the direction? It's a k cap. Very good. Now you have been given electric field. This is 3I plus 4J plus 5K. Flux, it is E dot A. Flux is equals to E dot A. When I perform a dot product, I know that only K terms with having an K would be the remain, and other would be a 0 due to cos 90. So the answer should be 5 multiplied by pi into r square. Gauss. Yes. Will you be able to solve something more? Are you sure? Let's move it. Second, let's say you have been given y square plus z square is equals to 25. This is a circle. Having radius r, and here r square stands for 25, so r stands for 5. And electric field that you know, that is of 3I plus 4J. plus 5k. Now find out the flux. Do it on your own. Do it quickly. Do it quickly. What would be the first task? Make a circle. Make a circle that is in YZ plane. Let's say this is YZ plane. This is circle. This is its radius. It's a 5 units. Now, what is the area vector? It's a pi into r square. This is 25. It would be here absolutely okay with this. Now tell me the direction. Yes, this is y, this is z. So x would be in upward direction and it is perpendicular also. So this is 25 pi I cap. Yes. Did you do the same thing? If yes, very good. Now let's phi is equals to E dot A, where E would be 3I plus 4J plus 5K, while area vector would be 25 pi I cap. So if I multiply I cap, it's a 75 pi Gauss, because other terms would be the 0. Yes. To find this interesting, shall we move for one more question? Are you sure? Okay, let's do it. Next question. The relation bounded by that curve would be x square plus z square is equals to 9. And electric field was 3I plus 4j plus 5k. Yes, you did it correctly. Let's say this is x, this is z, this is a circle having a radius 3. Very good. Now what would be the area vector? What would be the area vector? It is pi into r square. This is pi into 9. In which direction? In which direction? It is in j cap, because the area vector should be having a direction which is perpendicular and from the outside the plane. So now flux is equals to E dot A. Now flux is equals to E dot A. So this is 3I 4j plus 5k. This is 9j. So that should be equals to 4 into 9. This is 36 pi Gauss. Yes. Now are you comfortable with this? Will you be able to find it out the flux through surfaces? Are you sure? Are you sure? Okay. So now let's find out electric flux through the cylinder, and they have given that direction of electric field would be like this. Direction of electric field will be like this, in positive x direction, I should say this. So how could I calculate this when there are certain 3D kind of object is there? When there are certain 3D kind of object is there and I need to find out the flux. So first I need to calculate number of surfaces this body possesses. So if I number this, I should say this is the first disk, this curved surface, this is the second surface, and one more disk would be there at this place. Let's say this cylinder is having a radius of r and this is having a length of l, and I need to find out the total flux. So what the situation would be, flux total would be the addition of flux 1 plus flux 2 plus flux 3. So I know that when flux is required, I require two things. One is the electric field, or rather I should say direction of electric field, and second I require the direction of area vector. Now do this. Let's say for the first surface direction of electric field will be in this direction, but area vector, it should be moving outward, and perpendicular, so in this direction. So in this case, angle between E and A, it is a 180 degree. Yes. Okay. Now move to the second surface. move to the second surface. What would be the situation? Direction of electric field would be in this, but as it is a flat surface, it is a flat surface moving outward. This is the direction of area vector A, and this would be the 90 degree. Yes, can you do this? Okay, let's move to the third. Direction of electric field in this, area vector in this. Yes, can you do this? Very good. Now in first case this is equals to EA cos 180 degree, plus in the second surface this is EA cos 90 degree, plus third surface this is EA cos 0 degree. Here here it is EA cos 180. This is E multiplied by pi r square multiplied by minus of 1. This is cos 180 minus 1, plus here it is a cos 90 degree. Cos 90 would be a 0, so this term would be a 0, and cos 0 is the 1, so I should write as an E into pi r square multiplied by 1. So this is positive number, this is negative number, so this whole comes to a 0 Gauss. This all comes to a 0 Gauss. This is flux total. So revise it very quickly. What I need to do is I need to find out the number of surfaces it is having. So through when I need to find out through a cylinder, when I need to find out through a cylinder, what I need to do is I know there are two discs, one and second, and the other is the flat surface. What I can say is other is the flat surface. I need to find out the direction of electric field at every surfaces. I need to find out the direction of area vector at every surfaces. Just find it out their angles. And then apply the EA cos theta. Yes, would it be easy for you? Can you do this? Let's do one more very interesting question. You need to find out electric flux through a cube. So first let us assume a cube in front of you, and direction of electric field is given like this. Now how many surfaces does a cube is having? How many surfaces? Tell me. In whatever the room you are sitting, let's consider it as a cube only. Now tell me the number of surfaces. There are 4 walls. Yes, first, second, third, fourth. Look at in front of you. Look at right side to the you. Look at left side to the you, and look at the back end side. It's a 4 walls. Fifth one is the ceiling. Can you see it? Yes. And sixth is the floor. So if I numbered this, because it's a two-dimensional diagram, I can write like this. This is the first, this is the second, this is the third, this is the fourth. Yes, and this surface which is coming out, it is a fifth surface. And there are one more surface which is behind to it, I cannot represent it at the back end side, so I write like this. It's a sixth surface. Can you see it? Would it be visible? Is it visible? Okay, let's move on. Now what you need to do is you need to just calculate flux through each surfaces. So what I should write is flux should be is equals to flux through 1 plus flux through 2 plus flux through 3 plus 4 plus 5 plus 6. Now let's do this very quickly. So here in this situation, in flux through first, this is direction of area vector. Always try to look at your room. It's a wall number 1 which is left to you, which could be a left to you. This is direction of electric field. This angle is 180 degree. Now let's move to the wall number 2. which may be right to you. This is direction of electric field. Even area vector is moving outward, so this is area vector. Yes. Now let's move to the floor on which you are sitting. This is direction of electric field E, and this is direction of area vector. This is 90 degree. Now let's look at the ceiling. Let's look at the ceiling. This is the direction of electric field E, and this is the area vector moving outward. So this is even 90 degree. Now let's look at the surface number 5. Let's look at the surface number 5. It's a wall which is in front of you. It's a wall which is in front of you. This is for the fifth surface. This is the direction of electric field, and its area vector, again it is a perpendicular, so this is 90. For the sixth, it is a back end side of wall. It's a back side of wall. Again, for this, theta would be the 90 degree. So if I summarize this, that leave it on the first and second, and think about the 3, 4, 5 and 6. All this having E A cos 90 degree. All this are having E into A into cos 90. And when I do this, E into A into cos 90, that comes to a 0. So all this are having a 0 components. Now, what would be the flux 1? It's a E A cos 180 degree. That flux is E into A into cos of 180. Now cos 180 is minus 1, so this is minus of E into A. If I say it is a cube of side L, so I can write like this, it is minus of EL square. And if I choose flux through second surface, it's a E into A into cos of 0 degree. It's a E into A into cos of 0 degree. So this would be E into L square. Yes. So if I calculate total flux, this all are 0 as it is a 90 degree, and this two remaining term, this is minus and this is of plus. So again this would be a 0. Again this would be a 0. Would it be clear? Would it be clear? Are you sure? So will you be able to solve this kind of questions? Are you sure? Yes. Let's look at the numericals. Go through the question fast. Go through the question. What they ask is, they have been asked that electric flux is defined as the number of lines of forces passing blank through the surfaces. Would it be normally or parallel? Yes, correct. It is the passing normally through the surfaces. Let's move to the next. Very quick. Electric flux is an elementary area defined as the blank product of area and the field. To remember the relations, it's a phi is equals to E dot A. It's a dot product. So when we say dot product, it is a scalar multiplication of two vectors. So the correct answer should be a scalar. Yes. Next, go through this. I have already drawn a diagram for your help. It is not given in the question, but go through this question very quickly. Read it very carefully. They have given that flat base area of a hemisphere. This is having a radius of A. This is having a radius. This is having a radius of A. With no charge inside, it lies in a horizontal plane, and a uniform electric field is applied at an angle of 45 degree with this is 45 degree with the vertical direction. This is the direction of electric field. Yes. The electric flux through the curved surface of hemisphere. Yes, this is the curved surface. This is the flat area, and this would be the curved surface. So this is the electric field. This is the area vector. So if I make a theta over here, then my this component would be E cos theta. Yes. Now understand that this E cos theta and area vector are having an angle of 0 degree. Again I repeat this, angle between E cos theta and area vector, it would be at 0 degree. So what I can write is, it's a phi is equals to E a cos theta. Yes. So this is equals to E multiplied by area. It would be a pi into a square multiplied by cos theta. That angle is 45 degrees. So cos 45. And while I write this, it would be an E multiplied by pi r a square multiplied by 1 by root 2. So this is the flux. Unit would be the Gauss. Unit would be the Gauss. Is it clear? Okay, let's move to the next question. They said that 8 dipoles of charge of magnitude E are placed inside a cube, and the total flux coming out of the cube will be, that means, let's say this is a cube, this is a cube, and they have put certain dipoles. They have given the number 8 dipoles. So for flux, one relation will be that we'll learn in the next classes. It is a q enclosed by epsilon naught. I know that when one dipole is there, one is having plus q, another one is having minus q. One is having plus q, another one is having minus q. So this net charge would be a 0. So this is the case. But remember this question for next classes. It will help you. So this is Gauss law that we learn in the next class. But remember this. This will help us. Flux is equals to q enclosed by epsilon naught. Move to the next question. Read it. Done. What they have been given is, it's a square frame having side L meters, is in the plane of the paper. It is in the same plane where your paper is, and the uniform electric field is also in the plane of the paper, is limited only to square surfaces. Okay, the electric flux in SI unit associated with the surface. Now this is direction of electric field. Now find out the direction of area vector, where it would be. Find out the direction of area vector, where it would be. Yes, it is perpendicular and outward to the surface. It is perpendicular and outward to the surface. So outward to the surface can be represented like this. So here theta, here flux is equals to E a cos theta, and theta would be equals to 90 degree because electric field is in I cap, and area vector, it is in the k cap. It is in the k cap. When we know the direction and that converts to a 0, we don't even bother about whatever the magnitude would be. So this is equals to E into a into cos of 90 degree, and this cos 90 represents 0, so this flux would be a 0. This is cos. This should be the answer. Correct? Yes. So will you be able to do this? Let's shut it down here. In this class we have discussed about the flux, number of electric field lines that are crossing through an area perpendicular to it. We have gone through various surfaces through which we have find it out the new flux, and we did certain questions. But flux is associated with Gauss law as well. So in very next class, we will be doing Gauss law and its applications. So do one thing, at least do a 50 to 60 numericals. I said numericals, not a theoretical. 50 to 60 numericals from the topic Gauss law. This will help you. This will help you to find out the flux. So at least do questions that can be solved with the help of flux only. Yes, are you clear with this? Okay, bye bye, thank you, take care, goodbye.